everyone. So we're going to be looking at exercise 8F today. So the focus of exercise 8F is finding the nth rule when you're dealing with geometric sequences. So again, we're going to be using the n value to represent the one we want to find. And this is a fairly simple, straightforward formula when you know which particular value you want to find, and the question doesn't ask for you to write out the recurrence relation one after the other. So when it doesn't specify for that, and we can launch straight in and look for a particular value, we tend to use the nth rule for that. Alright, so again, the notes are up on Compass for you, and I'm just focusing on the examples today. So we'll get straight in with one of the first examples. So when we have the rule for the nth term in the geometric sequence, we have VO is equal to the principal, Vn plus 1 is equal to the rate raised to the power of n. Okay, so if we have to find the 5th month or the 5th year, we raise the rate to the power of 5. Okay, so that's what the n stands for here. And then we multiply it by the principal, VO. So that's the rule for finding the nth term in a geometric sequence. Alright, so say we have a principal value of $10,000 and that's invested into an account earning compound interest at the rate of 9% per annum. So remember that the term per annum means per year. Okay, so the recurrence relation that we would use for this is Vn equals, so remember R is the rate, so 9%, if you divide 9 by 100, you get 0.09. And remember, we add the 1 because we want the whole amount plus the 9%. So it's 1.09 raised to the power of n multiplied by 10,000 because that's our principal value. Alright, so what is this investment worth after 4 years? So we've got 1.09, we raise it to the power of 4 and then multiply by the 10,000. So for V4, so the 4th term, we are going to have a value of $14,115.82. Okay, that's when we compound yearly. Alright, find the amount of interest earned in the 4th year. So take note of that. That's a difference in the question. This time what we're asking is, what is the interest added in that year alone? Now, there's 2 different methods for this, and I'm going to go through both of them. And it will depend what the previous questions have asked you to do as to what might determine which of these methods you will use. Okay, so method 1 is if we work out V3, so the previous year, so we go 1.09 raised to the power of 3, multiplied 10,000. We find that this account is going to be worth $12,950.29 at the end of the 3rd year. Now, this question is only asking for the interest part. What is the interest added in the 4th year? So if we work out what 9% of that value is, we will have just what is added to the account. So we can work out what 9% of the V3 is. So 9%, so remember when we convert 9% to a decimal, we have 0.009. Oops, I think I said that wrong. 0.09 is what I should say, times this value, so the 12,950.29, and that tells us that the interest earned in the 4th year is going to be $1,165.53. Okay, the second method is, since I've already worked out the V4, if I work out the V3 and just take them away from each other, I will get the interest that was added in the fourth year. Okay, so I can take my V4 and I can subtract the V3, and that will literally just give me the interest that was added in that fourth year. So those are the two different methods that you can use to answer this type of question. Obviously, if you haven't already worked out the V4, you might go with the top method. But since we'd already worked out the V4, it's quicker for me just to work out the V3 and subtract them. And as you can see, I get exactly the same value. There's absolutely no difference. They will both give you the same value, but those are the two different ways of doing this. All right. If the interest compounds monthly instead of yearly, write down a rule for the value of the investment after n months. So remember over here in this question, we were compounding yearly. So we worked it out for yearly. This time we're going to compound monthly. And the thing is, with compound interest, the more compounding periods you have, the higher the interest goes. Okay, so in an investment, the more money you get. So if you're investing money, you want to try and have as many compounding periods as you can. When you borrow money, you want to have the least number of compounding periods possible. Okay? So, the first thing that we're going to have to do is, because we're compounding monthly, is we're going to have to play with the rate. So remember, our rate was 9% for the whole year. We now have to share that 9% over those 12 months. So we take our 9% and we divide by 12. And that gives us an answer of 0.75%. Okay? So remember, we don't want the number as a percent. We need to get it into a decimal. So to do that, we're going to divide it by 100. Now remember, this is an investment, so we want the whole of the investment. So we have to plus 1. So we have 1 plus 0.75 divided by 100. That gives us the rate value of 1.0075. So that's the monthly compounding rate. Okay, so we can now work it out. We've got Vn is equal to 1.0075 raised to the power of n multiplied by $10,000, where n is going to represent the number of months. What is the investment worth after 48 months? So 4 years. So we have V48 is equal to 1.0075 raised to the power of 48 multiplied by the $10,000. And the answer is $14,314.05. So let's take a look at this one over here. Now remember, this was compounding yearly. So this only had the 4 compounding periods. So it's worth 14,100, whereas when we compounded it monthly, we got 14,300. So as you can see, the more compounding periods you have, the more the investment grows. Because basically you're being paid interest on the interest. So every time it compounds, you get a little bit more because you're getting interest on the interest. We only got that 4 times here, interest on the interest, but we got it 48 times here. And that's why our value is a little bit higher. Okay, so that's been looking at an investment situation. I'm going to rub this side of the board off, and we're going to look at a depreciation setup. Just give me a moment. All right. So remember, when we depreciate, we're reducing the value. So we're taking it down. Imagine a company has a computer system and it costs $9,500 to buy. And it's going to reduce, it's going to depreciate, so it's going to be a reducing balance. Depreciation. Of 20% each year. Okay, so the first thing we want to set up is our recurrence relationship for this situation. So our VO is obviously going to be 9,500, VN plus 1. Now, to work out this rate, we've got 100% minus the 20%, that gives us 80%. So at the end of the first year, we're going to have 80% of the value left. So we don't want to put 20% in here. We need to put in what is actually going to be left. So we started off with 100%. We're going to take out 20%. So we need to use this 80% value because that's what's going to be left at the end. Okay, so 80% as a decimal becomes 0.8. So our Vn plus 1 is going to equal 0.8 multiplied by Vn. Okay. So, for the nth term, we're going to have Vn is equal to R raised to the power of n multiplied by the VO. So the Vn is going to be 0.8 raised to the power of n multiplied by the 9,500. If we're thinking about this computer system in 8 years' time, other than the fact that it will be completely obsolete and none of the software will work and everything else will be wrong with it. But if we want to find what it's worth after 8 years, we are going to go V8 is equal to 0.8 raised to the power of 8 multiplied by 9,500, and that's going to equal 1593.84. I've just written 5. So it started off 9,500 for this computer system, and after 8 years it's down to $1,590 odd. Okay, so that's how we deal with depreciation. So we start off with the 100%, we take away the rate of depreciation, and we use the amount that's left in our calculation. All right. That should help you get on with exercise 8F. I will see you in the WebEx class. Bye.